Hi again. Now we will start a new chapter. It's on benefit reserve. We're not gonna get into more details. It's just like an introduction because our semester is limited in time, so we will not have enough time for full treatment of reserve issues. But we will get the basic idea behind the benefit reserve. Just if you recall what we have done so far in this course, we looked at A. And A, we said this is the question we try to answer here for A is what is the value of benefit insurance? And then we looked at small a is, now this is the annuity. Then with these two we said, okay, now we're gonna give this 1 unit of insurance, and we will receive a premium that is annuity. What level of a premium should we charge? So this is the level of a premium we need to charge. Now we solved for this, the P. So let's say at age 30, at age 40, we decided the premium that will actuarially balance the system is 10 cents for every 1 unit of insurance or whatever. Now moving forward is, now policy is issued. To X, to an individual age X. Now in X plus 1, X plus 2, X plus 3, we need to keep some money for meeting the future, especially if you have a large cohort. So the question we are looking at what or how much reserve we should keep. The reserve we should keep to pay future benefits. Right. So we need now, and this is what we call it the benefit reserve. So we need to look at how much we should keep to pay benefit reserve. Imagine if you are having, let's say, a cohort of 1,000, they are insured, everyone gives $1, just one example, or 10 cents. So you might want, like a logical idea, we keep all the money we collect in the premiums, but this is not the case because death happens towards the end, mostly that you'll have more obligation towards the end, but you get benefit at the beginning. So you'll have lots of money at the beginning, and at the end you need to have lots of cash to pay out the benefit that you issued. So you to keep it from, let's say, year 30 to until death happens, year 70, it's a lot of money. It's a lot of money. You better invest it, but you need to keep some reserve to meet the obligations. So that's why it's always important in actuarial science to calculate the reserve that you need to keep. And the basic idea here that this is X. Now this, you issued the insurance, but now the time becomes X plus T, and you are here now, but you issued insurance here, and now we are here. So you already collected lots of P's here, and probably a couple of people or few people that die here you give benefit at death. But you still, now you have the future you still have obligation. If you have a large cohort, you have the obligation for the future, how much you need to keep. What we looked at, remember that we said L here, and we looked at expected value of the loss. Remember we said it's 0, right? Because you equate between what you get and what you get in benefit, future benefit. What you get in a future premium, you equate it with what you get, what you pay out. At this moment here, we are here, and this we give it 0 here, or sometimes we don't have it, but here expected, what we call it TL, and this is the reserve at time t, and this one here, it shouldn't be equal to 0, right? Because very likely here the expected L, which is expected loss, but not at issue, at time t, will be bigger than 0, right? Here it's 0, but because here you collect so many P's, but your obligations are around here. So usually this shouldn't be it shouldn't be zero. Well, there are certain situations when it's zero. We'll look at it. We are trying to look at the expected loss at this moment, and there are two methods to do this. And the two methods here, one is prospective method, and this is exactly what we looked here. You are x and x plus t. You try to look forward and calculate how much you need for the future, and you look at the expected of the value of the L at this moment. But by looking forward, you look forward how much I'm expecting to pay out, and you deduct from it how much you are expecting to receive in premium. Right? This is prospective. There is another method which is the opposite, retrospective method. The retrospective method, as you would expect, you are at x plus t and the policy is issued at x. You look backward. You say, well, we received P's, then you bring the P's here, and you say we paid whatever benefit we paid here, you bring them back here. And this is now you accumulate them. These guys, you accumulate them. Here, what you get, the P's you get, and what the BTs you pay the benefit. Now you get them back, the discount here, actuarial discounting. Here it's actually you look backward and you bring them forward. Retrospective, you look backward and you bring them forward. So here you accumulate. Both of them, they should give you the same answer. But for us, for this, especially that we are looking at introduction, we'll look at only prospective, looking forward in the future, right? So let's now, because we're going to look only at the future, right? But it's good to know that there are two methods. Now let's look at this method here. Remember, here at time 0, expected value of 0L, we already calculated. We set it equal to 0 to compute P. From here, you compute P, right? And let's focus now at the continuous case. Continuous case. In next session, we look at the discrete case. Now you calculated P of AX because it's here. And this is, you find it to be a fixed number, 10 cents, 5 cents, whatever, right? So now when you are here, and we need now we are here. Here what you are expecting in the future, right? The death, right? So death might happen somewhere here. So death might happen here, and this is when you pay the unit of insurance. So you discount it back, or let's define first L at time t. Now you have V, the discounted value, but it's not Tx, you discount it back only to t, so you only x plus t, right? And this is here, t is equal 0, time of issuance of the benefit, right? But now this is what you are expecting to pay. What you expect to get is now you collecting premium. The premium, we already set it at this level, determined at time of issuance. So this is the premium at time of issuance, right? So how many premiums I'm still getting? And then we multiply it by the annuity until time of death. Tx minus t, because it's continuous case, right? This is the random variable. So, and this is the present value, right? Now we need the actuarial present value, right? As always, we take the expected of TL, and it has a notation, actuarial notation. For the continuous case is V, and this is not the V discounting, this capital V. This is small v. This is the discounting factor. This is the V for reserve, continuous case. And to tell us that continuous case for the premium is paid continuously, but also to tell us that we are looking here at a whole life insurance that is paid at moment of death. Right? Now we take expected value of VTX. We subtract T because we are not at the beginning, we are here now. Right? Minus remember the premium is already set. We calculated. How we calculated? We at time 0 we look at the expected value of the loss. We equate it to 0 and we solve for P. Now P is constant. Oh, there is a bar here, sorry. P is a constant, but and multiplied by the expected value of the annuity. Capital T, but we subtract the small t. Right. So this one can be written again VAX. This is the expected value of loss, not at issue, but loss at time t. Expected value of loss at time t, which is the reserve that you need to keep, is the expected value of the payout, how much you are expected to pay in insurance. And this one, the expected one, this will be A capital, because it's continuous, it pays at time of death, X plus T, right? So here, this is the age X plus T subtracted from. Now again, remember, the premium is the premium that you are collecting at time X, not at time X plus T. The premium that you collect at time X, which is a fixed number, multiplied by A, the annuity X plus T. It's very important, and this is very, very important. You need to memorize it. Very important. And this is, we took the expected value. Now let's take the variance also. I'll use var for variance. This is variance, right? Of variance of what? Of the TL, the loss. And this is very straightforward. It's the same, the first half of it is the same, PAX divided by delta raised to 2. Up to this point is the same, but when we multiply it here, we multiply it by x2 plus t minus ax plus t raised to 2. Second moment minus first moment. Those two equations are very, very important to keep in your mind, right? You need to solve your problems based on this one. Let's take one example here. As always, we take the easy case, uniform. X is uniform on delta is 5%, the interest, force of interest is 5%, and the question tells us T10 V continuous for A30 continuous. And what is this one here? 0, 30, 40. But it tells us here is issuance of policy. And now we moved forward. Now we are here. We need calculate reserve here. So we need to find reserve. What is the reserve? So this question is, what is the reserve to keep, right? We are at age 40, but it's issued at age 30. So let's always in actuarial mathematics write the equation and see what you have and what is missing. This one, straightforward, we apply the rule. Remember which rule we're gonna apply? This one. So at 1030 we're looking at the future. What is the expected value of the future payout? The future, and that's why we call it prospective. A future is we expect to pay for from like an annuity, not an annuity, an insurance benefit of $1 from 40, because the past we already passed the 30. From 30 to 40 we already passed. We are here. And how much we gonna collect? We collect whatever the level of the premium that we collect. So the premium at age 30, right? The level of a premium. So premium is calculated here. But we are here because the premium, this is when you issued in the contract, the insurance contract, you specify the premium at this time, at time of issuance. So it's already fixed. But we need to get a series of payments. So we multiply it by, now it's again 40, because you're going to collect from 40 and forward, right? Whatever the policy tells us. Now this is uniform distribution. So we need to calculate all pieces here. So let's calculate O40. How we calculate A40? The first one, the insurance, remember it's 1 omega minus at age 40 is 60, right? 100 minus 40 multiplied by A60. This annuity certain, right? Which is 1 over 60 multiplied by 1 minus, we did it many times, if you calculate this one, the A40, the insurance benefit, if you calculate it, we already calculated, you can go back to your notes, 3167. Now what else? So we got this one. Now from here we can get this one. So now A40, right, divided by delta, which is 1 minus 0.3167 divided by 0.5. And now we get A40 to be, which is 13.665. Let's keep them so we get them. What else? So we got this, now we need this one. Now remember, it's the premium is set at time of issuance of the policy. And how we calculate this one is A30 divided by A30. So we still need A30. And now so A30 we still need it. Same logic. Now we have 100 minus 30 is 1 over 70 multiplied by 1. Well, let's just write it because we've done it so many times, with the annuity certain for 70 years. I just wanted you to keep this there. And this one is 70 is 0.27708. Keep this one now. Now we need A30, which is 1 minus 0.277 divided by 0.5, which will give us, if you calculate it, because we've done it so many times, we know these numbers, but I just repeated again the method. Now remember why we're doing this, because we need to calculate this one. So this one will be 0.27708 divided by 14.4583, which is the premium at 30. Yeah, you should calculate it to be where we got this from. Sorry, we calculated it to be 0.19165, right? So now we got this one as well. We go back to our equation. We got all pieces now to calculate this one. So now let me use different color here. So A40, which is 0.3167, subtract from it, we just calculated it in a second, 0.19165 multiplied by A40. Sorry, where is the A40? We need to go back to the A40. 13.65. Which is 0. Let me double check it just to make sure. We have the 0.3167, we subtract from 0.1965 multiplied by 13.665, 04. Can I just do it again? 0.3167 minus 0.01965 multiplied by 13.665. Correct, yeah, that's correct. So the reserve you need for every $1 of insurance at time 10, you need to have 5 cents for every 1 unit of insurance, right? You need to reserve this one. Now this is straightforward. You put the rule and then you look for what you have. Now what if you want to calculate the variance for the same one? Now we need the variance, calculate the variance of 10. Remember, the reserve is the expected value of the loss. Now we need to calculate the variance of at time 10, right? TV. Now we need the variance of time L. We just plug in the rule, which is 1 plus, remember, it's the same one we did before, which is here, sorry, you have P, whatever the at time of issuance, and then delta, you raise it to 2, and then you have 2A40 now, minus A40 to 2. Okay. So if you plug in the value here, we already calculated the PA30, which is 19% if I remember, 0.1965 divided by 0.52. Now we need 2A40. This one we don't have it. Let's take it on the side here. 2A40. Let's take this one on the side. This one is the same thing, 1/60, because it's uniform distribution, omega minus x. And now you also do the same thing here, 60, but at 2 lambda, 2 delta. So this one will be 1/60. If you do it, it's 1 minus e minus 2 delta, which is 10%, multiplied by 60 years, divided by the 10%. The 2 delta. If you do this one, you're gonna get for the 2 alpha, 2 delta, or the second moment for the insurance, this one. Now this becomes here 0.16625. We subtract from it A40. We already calculated earlier. We go back to the A40. Capital is 3167. 3167. Three, 3167, we raise it to 2. So the variance, if you calculate the variance for this one, it will, I didn't calculate it, so let me, so let me calculate it quickly. 0.16625 minus 0.3167 raised to 2. Now we need to calculate also 0.01965 divided by 0.05 plus 1 raised to 2 plus or multiplied by I got this value. This is the variance for the insurance, right? So yeah, I mean, it's straightforward. All you need to do is just you plug in your values. You know, as yeah, what if we take this, as always, we take the second example, the example of x is exponential with the mu, the general form, and delta. Find, you know, t v a x, right? For any form, always 0. The reserve for exponential distribution is 0. You can calculate it, it will give you 0. You calculate it using the same form here, but let's not waste time. It's like if you use the variance, this one, you use the variance for any value. For exponential distribution is memoryless, so it's always, there is, you know, there is no reserving. It's always 0. The reserving is always 0. But now we've done a lot of we've taken so many formulas, but actuarial science is all about formulas. Some of them make sense. Some of them you can derive them yourself. I will not derive them. I will keep them as a homework for you to derive them and arrive at these different formulas. But why you need to have so many formulas? Because sometimes it's easier to use one of them. So let's take other formulas for prospective benefit reserve, which is TVAX. Continue. You know, we talked, the first one is, we remember the first one, the standard one, we said we look at how much we need to pay, subtract from it the this one, the annuity, the stream of income for premiums. This is 1. Now 2, you can also TVAX. You can now, if you know, you like, we'll take a few of them. Now if you replace this one, no, I mean, if you replace this one with the premium, or this one with, like, and then you play with it, you can think about it. Let's take the general form and then we look at it in using logical interpretation. So if you factor out Ax plus t, what you will end up with 2 premiums. One is bigger. Which one is bigger, the one at x or the one at x plus t? If you take a premium calculated at x plus t, it should be bigger, because now you're getting closer and closer to time of death. So if you issue an insurance, for a life insurance for somebody age 70, it will be more expensive, the premium for it will be more expensive than the premium that you issue for an individual age 30, right? So you take the bigger one, and you subtract from it the smaller one. So reserve at time t for a policy that issued at time x, you take the difference between the 2 premiums, the premiums that was calculated or included in the policy, or calculated, you take it, this one, and you look at what benefit you would, what the premium you would have calculated today, and that difference you take it as if it was an annuity of the of differential of those benefits, right? It makes a lot of sense to think about it this way. Now let's take the third one. Another formula here, TV, the same one, of AX. Again, the V is the reserve for policy whole life insurance, continuous one, that issued for age X. Is now, imagine if you factor out the life annuity, not a life annuity, if you factor out the AX, if you go back to the original one now, let's factor out this one after little manipulation. Let's see what you are left with. What you are left with, the premiums, is, remember, there is one is smaller, one is bigger. The bigger goes to the denominator, so it will be fraction. It will, if the bigger goes to the numerator, then it will become negative. We don't want it to be negative. So you take the bigger one here and the smaller one here. But this one you multiply it by the Ax plus t, right? So you see what we are doing now. Now let's take another case. All of those make sense and you should memorize them, all of them, because it's then in the exam you have variety of options. One will be more efficient than the others to calculate it. Now let's remove, just keep it between AX and AX. You can, all of them, you can derive them so easily, but it's not very important. Now the bigger, you know, like the whole life with the value of insurance at time t is bigger than at X plus t is bigger than the value of the discounted value at younger age, right? It's that because you discount it for longer period. So the $1 of insurance issued to somebody age 20 will not be as big as the one that is issued for somebody's age 80, right? Because 80 is closer to death, so it will be higher value, right? So we take the bigger one, subtract from it the smaller one, now divide it by 1 minus the smaller one. That's another one. Now the last one is, if you take the same one, TV, now again continuous, you take AX, the same one, but we're gonna use now not the relationship between the small a. The small a 1 minus. Now we're gonna have a fraction a here and a here. Now which one goes to which denominator? The bigger, again, you don't want the bigger one to be in the numerator, then the whole term will be negative. You cannot have, you don't need to have negative one. Right? So you take the bigger one, you get the bigger one in the denominator. But let's think about the bigger one. Which one is the bigger one? If somebody paying a premium, paying an annuity at age 30 will have so many years to pay at the beginning of every year in comparison to somebody 80. So the one is at younger age will be bigger, right? Because you have so many years to pay. So this one will be X plus T here and here X, right? Oh, sorry. This one should be, can I just verify it quickly? Sorry, this one is AX plus T. Yes, the smaller one, I mean the 80 years old, you have shorter life for annuity. This is the bigger one. It seems I put it wrong in my note. But it's always use common sense, right? I wrote it wrong in my note, but because the logical thing. The bigger one should be the denominator. The bigger one is the younger one, would have so many years to pay for the annuity, so it will be bigger, right? So now you have 5 of them, and which one to choose, it depends on the question. Let's take a real, like an actuarial exam question, just to see when we can choose which one to use. And this is Society of Actuaries exam, SOA exam. It says that X is uniform. It tells us X is uniform between 0 and 100, right? And we are given some information here. The first one you are given is A40. This is the annuity certain. 40 is 17.58. Now A50, this is annuity certain, is 18.71. Now A60 is 19.41, right? So you are given this annuity certains. You are also given interest rate. You don't need interest rate, but in case you need it. And what question here is to tell us to find TV A40. And you know, in these actuarial exams, time matters. You know, time matters. You need to be efficient, solving problems quickly, so this way you can save time. So you need to select the formula that is the safest one. Out of the many of them, I would select this one. I would select myself this one. Why I would select this one? Because there is relationship between the annuity certain and A capital. So this way I can save time. So what I would do always, I would write Ax+t, which is 50 minus 40 divided by 1 minus A40, right? Many times you will forget, and remember that you used one young guy, one old guy, and just think logically of which one is bigger, right? So now A50, now you take them on the side, you need A40, so 2 terms you need, and A50. And A40 here between 0 and 100, so 1 over 100 minus 40 is 1 over 60, A60, right? Do we have A60? Annuity certain, it's given here. So we don't need even the interest rate, we don't need it. A60 here is 19.41. And 50 is 50, and now A50. I think we have 50 here. We have the A50, which is 18.71. You notice that they give you an extra one, an extra term here to confuse you. They give you this one, you don't need it, the 40. And now this 1940, if you do the calculation, this one will be 3742, and this one will be 0.3233. Actually, I said you don't need, you don't need the interest because you're already given this one, right? And now you take this up here, then the final answer will be 0.0752. So you choose the one that, you know, the one that suits you out of these many formulas. So we finish, you know, like the continuous case. We have one more session on the discrete case with a couple of examples, and we are all set, all right?